There's another type of an exception, and this is called an incomplete octet. And that's some smaller atoms, atoms of elements that are smaller, beginning of the periodic table, can be stable with 6, 4, or just 2 electrons. And we've already looked at the one exception of hydrogen. Because it's in period 1, it can only hold up to 2 electrons, and it only needs 2 electrons to be satisfied. That's why it's always terminal, and we build stable molecules with just 1 bond on the hydrogens. It only needs 2, okay? So when you're looking for needed, it only needs 2. And then you have to remember boron. Boron only needs 6, okay? Down here, hydrogen needs 2. Beryllium only needs 4. And if you look at where they are on the periodic table, beryllium is small. It has 2 valence electrons. Boron is small. It has 3 valence electrons, okay? And so those are just special cases. And you can predict the bonding in this by doing the S equals N minus A rule. The available number of electrons here in this case is 24. The needed, this is where you have to be careful. Boron only needs 6. There's 1 of them. So instead of putting 8 here, you just put a 6. Fluorine, there's 3 of them. It still needs 8. So the total number of needed here is going to be 30. And so when you do your bonding, 30 minus 24 equals 6. So that's going to predict 3 bonds for this particular structure, which is the correct prediction when you use the correct number of needed. So you have to remember that boron only needs 6. And so then you're going to come up with a structure like this. Okay? So that's just an exceptional. Boron, beryllium, and hydrogen you just have to memorize. 6, 4, and 2. Beryllium, the same thing. You can go through the same, try it on your own. You have the tools you need. Knowing that beryllium only needs 4, then when you do your needed accounting of electrons, then you're going to use here, instead of 6 like boron, you're going to use 4, and you're going to recognize that you only need 2 bonds, and so beryllium makes a stable molecule that looks like that. Okay, so those are some exceptions, either expanded or incomplete octets that you should do.